Hi everyone, and welcome to our What's New in 12D webinar series. Today we've got part 2. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator here at 12D Solutions. While we wait for everyone to finish joining and get comfortable, I'll be launching 4 polling questions. You'll have about 30 seconds to answer each and then I'll show the results. Firstly, we'd like to know, did you attend part 1 of this webinar series yesterday? Okay, it looks like most of us were here yesterday, but there are a few newcomers, so welcome. Next, we'd like to know, what version of 12D model are you using? Version 11, version 10, version 9, or earlier? Looks as though we're mostly on version 11 today, but we do have some people on earlier versions, so I hope that you're considering upgrading to 12D Model 12 in September. Next, we'd like to know, how many people are watching this webinar with you? Are you there by yourself, in a small group, or are there more than 5 of you in the room? So most people are there by themselves, but we've got some small groups and a few large groups there. Welcome everyone. Next, we'd like to know, which area of 12D do you use the most? Design, survey, drainage and water, or perhaps 12D synergy? Okay, a lot of designers here today, but also quite a few surveyors, some drainage people, and quite a few 12D synergy there. That's great. I'm sure we'll all get a lot out of it today. 12D Solutions will be releasing the new 12D Model 12 in September 2016. This webinar series will highlight some of the new features. These presentations are designed to give 12D Model users an insight into the new features and enhancements in 12D Model 12. We'll also be discussing some of the new features in 12D Synergy 3. Both new product releases will be showcased in greater detail at our upcoming 12D International Conference in July, but these webinars will provide an exciting preview of things to come. This webinar series is in 3 parts, so if you haven't registered yet for tomorrow's session, you can stop by our website and do so after today's webinar. During this live presentation, you'll be able to type your questions along the way as shown on the screen, and we'll answer as many as possible throughout the webinar. Any questions we don't have time for during the presentation will be responded to afterwards. Our main presenter today will be Dr. Lee Gregory. He's the Managing Director and Co-founder of 12D Solutions. We'll also hear from Peter Tainton of 12D Queensland, Rob Graham, our Resident Water Resources Engineer, and our General Manager, Joel Gregory. For now, over to you.
Thank you, Lisa. Just had to get technology working there. I can see we have a few people who didn't attend part 1. I'm sorry to say, but we gave out all the lucky viewer prizes yesterday, so you'll have to ask your friends what they actually won. Now, these webinars are to look at 12D Model 12 and 12D Synergy 3. Today we'll be going through part 2, and then tomorrow we'll follow up with the final one, and that's where we'll answer some of the user questions as well. Each part is different, and as you know, this is the 4th one for today, and so we repeat tomorrow's 4 times a day. Basically, we won't cover all the new features or much about them, and the conference will be having sessions there in the Birds of a Feather to go through more detail. Any of the people who can attend the conference, they'll also get if they're on maintenance, they'll get a technical preview version of 12D Model 12, so they can use it, use the things they saw at the conference, hence be ready when it comes out in September. Also, there's the Innovation Awards. You don't have to attend the conference to go for these. You can just even send in half a page or even a page if it's on something you've done that's a bit innovative, and share the $15,000 Australian prize money. It closes at the end of this month, so get your entries in pretty quickly. Yesterday, for those who weren't here, we did the attribute manipulator, tri-meshes, some BIM, drainage, new items in 12D Synergy 3, some network least squares, dimension leaders and tables, and labelling string attributes and properties. Today we'll use some of those things, go into more detail on some of the other modules. So let's start off, and the first thing we're going to look at is plan view favorites. This is new in 12, and what you're actually going to do, say on a plan view, you'll now see there's a little star there standing for favorites. And if you click on that, you'll see there's favorites, and if you click on the create edit, it gets up the create plan view favorites box. Now it's showing all the information that's actually on the screen at the moment. There's little ticks beside them so you can turn it off. So you're allowed to set whatever settings you want for a view, and you can start from scratch for this, but it's often good to start with a view and then save it away so you can use it in the future. So what you're able to do is you can apply any of these saved favourites to another plan view. And I'll get Peter to demonstrate these shortly. You can also see once you have a view, you can walk right on the favourites part and it just comes up with a list of plan view favourites you have, so you can just pick one of them and apply it to that particular view. You also can, they're used when you're creating a new plan view, so there's a new favourites on the create a view, and if you fill it in there, it'll use the favourites to set your view up for you. You also can do it from a chain and also in a macro. So again, we'll demonstrate those to you. Now, it's also exactly the same for section views. It has all the information for those, and there's all one for perspective views. The other new thing we've done is called plan view positions. Now, it's on the same little favourites bar, and you'll see there's one for positions. And again, what this has is just mainly positional information. So for a plan view, it's just got your minimum, maximum, X and Y. For a section view, it'll be the minimum, maximum chainage. And for a perspective view, it's your eye and target points. So you can save that information away, and then you can apply, in this case, to a plan view. You walk right on positions, and you can pick any of those. And you'll see this used throughout the webinars today. Again, they're there for section views and for perspective views, but the best way is we'll get Peter to show you how they work and how you work with models and things within them.
One of the exciting new additions to version 12 is the option to save favourites. The favourites reside under the star and are on section views, plan views and perspective views. So it's our perspective view here. We can save favourites, which includes the models and settings, and in this perspective view, the view eye and target, but there's also just a simple position one. So the position one just records the eye and target. Okay, so here I can just go to my position and go to intersection 1, and that's a view saved at that intersection with whatever I have on the view at the time. So I go back to my position, I can go back to my room. So you do the same thing in your plan views. And I have plan view ones, and I have a intersection 1. Again, simply just go to each area that you want to save. As regards saving models and to your perspective view, a bit like the VML, you're able then to record all the information about the view and even be able to take off models from that view. Okay, it's here under my favourites. I can go to create favourites, and here's a list of things that I can store. If I type in here my road design, I'm not really interested in the grids, and want the eye, target, and shade. Under models, I want all these models here to be added and saved, but I also want any other models on the view to be taken off. So I then put in a asterisk and write the file out. So not only can I then bring that back up for this particular view, I also can go under View, Create, Perspective View, and I can select the favourite and go Create. So it creates the view, exactly like the other one. Takes any, it's just adding the models on here, but if I did have models on the view, it would take those off and then add these new ones on and go back to our view setting. Simply if we go to our plan view, you can do the same thing here. I've got favourites saved, intersection 1 with tri-mesh, intersection 1 without tri-meshes. So there's the view with the tri-mesh. If I was to add them on, I don't have to remember all those models. I can just go with tri-mesh. So again, that favourite. Under models, they're just simply adding these on. In this case here, it's not removing any models from the view, it's just adding the tri-meshes on for me. In the section view, there's some favourites saved here as well. So again, you can save the models, information about grid, whatever's toggled on, annotations, extension corridors, and the viewpoint, and so forth. So quite comprehensive when it comes to section views. You can run these favourites, where I created the favourite manually creating the view. You can also run it inside a chain. So part of that option in the chain is to be able to automatically profile a string as well as do the settings. So we can run our chain here, standard profile section. Do and create the section view profile string that I set, and set all the settings for that view.
Thank you, Pete. So I think you'll find everyone will use that very, very quickly, favourites for the 3 different view types. Now, just a thing that's been here for a while is this 12DA library items. You can put data in a 12DA or 12XML file and then insert it later on. And I'll get Rob to demonstrate that, but he'll use it for a culvert. So those of you into drainage, we've got a few of them today, you can actually see how they can make putting a culvert in and then running it much faster. Right, Rob, I'll get you now to start.
The use of the 12DA library is a very quick way to create stormwater components. Going up to our file menu, down to data input, across to 12D, and down to the 12DA library, you'll notice that underneath the drainage tab, we've got several drainage components for easy insertion. Coming down here to our culvert dynamic, the big red plus sign indicates the insertion point. So if we come down here to pick our insertion point, we'll pick it in the center of the roadway where we'd like the culvert to connect. I do plan to use the models that are contained inside the file. The reason for this one is that it will contain the dynamic settings ready to have it begin analysis. Coming down below, a little bit of rotation wouldn't hurt, not really required, but if we rotated it 45 degrees, it'd be a little bit closer to the alignment we want. So we might as well ask for 45-degree rotation and then select import. When it imports into the models that were inside the library, the model will begin with the name culvert. And there it is down below. Now, of course, it's not going to be lined up perfectly in the right size. By having all the component ready to go, all we have to do is come down here to our strings, points edit move. We can select our upstream invert of it, drag that across to where we'd like that to be, probably near the head wall. And we go grab the downstream end of it, pick that up, put it where we'd like it to be at that end, do a save, close off that window, and then we've got our culvert ready to do an analysis on. Now, to perform the analysis on that culvert, we'll come across and select our drainage network editor, and we'll use our pick button and select the upstream end of that culvert. The changes we are going to have to do is go to the global tab and select our chin rather than the chin from the library. So we'll use our finished surface chin, and we do have a design chin, so we'll select that one as well. To make sure our culvert is set to those levels, we'll do a set to details, and yes, I'm sure, and we'll also go and regrade the pipes for it, and let's say yes to that. To see what that looks like, we'll pull up our section view. Let's do a window tile vertical. And on our section view, we'll go select a new section for that, so we'll go profile. Come across here, we'll make sure we hit our drainage string. That'll come up. Survey drainage, culvert. That's what we're looking for. And ours is sitting nicely underneath the roadway. Assuming that we're happy with the length of that, we're ready to start doing the analysis. On the catchment side, we would want to make sure there's a catchment area. So let's go put a 2-hectare catchment area at the top end, and we can go ahead and run our storm analysis. The storm analysis we'll do for a 5-year storm, and we're going to use the Canberra rainfall file. So we'll go run on that, and it's going to run the dynamic analysis for us with the flows generated from the design storms. Once that's finished, we're ready to take a look at the water levels and the flows through our culvert. So a quick review of the idea there, we'll go back to the editor and then finish, was that if we wanted to insert a culvert that we wanted to do the analysis on, rather than using all the standard create pipes tools, what we did is we went straight to the file data input, across to our 12D12DA library, and selected the components that we wanted to use directly out of there.
Thank you, Rob. And we'll stick with the theme of water at the moment, and this is a new module that we're introducing with version 12, and that's dynamic water supply. So it actually completes our trilogy for the 3 waters of water supply, stormwater, and wastewater. So what is the dynamic water supply? Well, it's a hydraulic analysis on water quality behaviour of pressurised pipe networks. And so it's based on the EPA net engine, and which we've made some modifications to. It can run for extended periods of simulation, so like for 24 hours. And the network consists of pipes, junctions, pumps, valves, storage tanks and reservoirs. It tracks the flow of water in each pipe. We also track the pressure at each node, the height of water in each tank, and you can track things like your chlorine, and age, and source tracing can also be simulated. It'll handle very large network sizes, and the system operation can use both simple tank levels and timer controls, or you can build more complex rule-based ones. To actually access it, you go in your drainage network editor and select water supply in your method. And then your pits and pipes will be used to set the nodes and links. For water supply, people tend to talk about nodes and links rather than pits and pipes. So under the pit tab, there'll now be a water supply section, and that'll actually allow you to select 3 types of nodes. They can be junctions, tanks, or reservoirs. So what are junctions? They can have multiple demands, each with their own time patterns. You can have pressure-dependent demands, say like sprinkler heads. For tanks, you can have storage tanks and reservoirs of any shape. They could be complex, plug flow, or 2-compartment reactors. As far as reservoirs, they're really for large storage supplies like dams, where the water really doesn't go down very much over the time. With the pipe tab, that looks after your links, and again, there's a water supply tab on there, and the types of links we can have are pipes, pumps, and valves. So for pipes, you can set minor head loss for bends, fittings, and so on. The friction loss can be using the Hazel-Williams, the Darcy-Weisbach, or Chesney-Manning formulas. And for the pumps, they can be constant or variable speed, and we can compute the pumping energy and costs. For the valves, there are a heap of those. There's the pressure sustaining valves, pressure breaker valves, pressure regulating valves, flow control valves, throttle control valves, and just a general purpose valve. As far as the water quality in the system, we can do flow tracing, watch the movement of various reactive materials, check the age of water, and can track the percentage of flow from a given node that reaches all other nodes over time. As far as results go, we can, for the nodes, have demand, head, pressure, and quality. And for our links, we have flow, velocity, head loss, quality, the status of whether the pump's open or closed, and the pump speed, valve section, settings, and quality reaction rate and friction. And any of those we can actually graph over time as well, but things we do in the drainage network editor. So here for link 113, we have the flow, and you can have multi-things. So in this case, we've got the flow, the head loss, and also an HGL value. The other thing you're able to do is you can import EPA net files to get you your nodes and your links. And once they're imported into 12D model, we can run our dynamic water solution on that file and network. So here's one linked in, brought in, and so we're looking at various aspects of it. So the dynamic water supply, it's a new module, and I'm certain everyone will have plenty of questions to ask once it gets released, and we'll be going into it in great detail at the 12D conference in July. So we'll have all the answers for people then after that. Now, drag and drop, that actually was introduced in version 11. Now, if a file cannot be dragged and dropped now, once you do try and drop it, a message will be written to the output window, so you know that nothing has happened. Because before you just saw nothing at all. This just lets you know, well, you can't drag and drop that file. For version 12, we are starting to add a lot more drag and drops in. At the moment, you can do it for cross-section plot files, long-section plot files, label map files, template files, but you'll find we'll add a lot more of them over time. With the CAD, again, we'll leave that till after the conference because it's easier then to show it on a bigger job. But a few things like the CAD text, the same as is there. For the CAD text create and edit, some of the new properties we added for 11 weren't actually in that. So we've got the new ones like the whiteout and that. All of them are now available from the CAD text create edit panel. The messages we write out, because a lot of these you can use typed entry for them, we've allowed you to split over 2 lines if it's too long for 1 line. And these two, copy and rotate many times. This is where you might want to do a lot of the copies one after another. You can pick the copy many option, and you can just pick one thing, copy it, pick another thing, copy it. You don't have to go back and pick the option again. So it speeds that up quite a bit. And with the CAD toolbar, where you use same as get information like color and model and so on, you now can pick tri-meshes, dimensions and leaders, and it'll fill information into there. Right, now with snippets and MTFs, we showed a few examples yesterday in part 1 of creating them in different ways. We're now going to look at creating tri-meshes from MTFs and snippets. We're actually going to look further at that. Pete's going to look at quite a complex road job just to say how it all can fit together and work with inside 12D model, and so you can produce everything for it, pipes, all sorts of things as well. We're finding here, definitely in Australia and New Zealand, that we have to do more and more detailed design because people want it for machine construction and also to go to BIM systems and that, so you have to have it modeled accurately. You can't just do a cross-section every 5 or 10 metres and who cares about the results. So I'll let Pete go through detail, just showing just how complex your things can be done if you really have to.
Design in V11 saw a change to the MTF modifiers and the introduction of tri-meshes. The modifiers have been expanded or been enhanced over the life of V11 and into V12. Smart changes continue to play a major role, and there are even smarter ones now. Pavement and curb streams can be created via modifiers and tri-mesh shapes as well. The combining of these modifiers into snippets aids in their use and promotes a standard approach to design. There are several snippets available in the library for the purpose of creating pavements, curved shapes, and even trenches. Pavements can also be extended to form the intersection with batter slopes. Design and other layer strings can be used along with external strings not in your design, such as the edge of existing bitumen or cutback strings. The appearance of layers in V11 has made this possible with the ability not only to create pavements, etc., that rival the traditional boxing, but allow an expansion of the design surface idea. This is continued into V12. The insertion of strings attached to design strings that do not distort the design layout. This is typically the creation of retaining walls and service utilities. Our road example here utilises all the previous mentioned options. It's a good idea to create aliases at the start of the job that can be used easily later on. So you may have an option where you're selecting the ends of the strings, the start of strings, at the intersections and so forth, and to repeat that time and time again would be quite laborious. So at the start of your job, save that off as an alias that you can access through every modifier. Make use of the regions, which allow you to collapse and expand groups of modifiers. Once we've completed our design steps, we can go to our tri-mesh creation. The typical library ones all start with the word tri. So you have a tri 2-point pavement design layer and a curve profile, and ones that introduce and use name grades. So typically for the tri-mesh 2 pavement, we'll be setting up an AC surface or a subgrade or sub-base material. There's a fairly good options here to do a user-defined naming convention, not only for strings but for models. You can incorporate in your naming convention the name of your alignment string, whether it's all part characters or none, attached to the particular layer that you want the pavement. And there's also an option to vary the depth types. So here we're looking at vertical. Do we want it normal? Do we want a top surface, or do we want the bottom surface? In this first one here with the AC surface, we want to create a name grade. So the name grade surface is a surface on the depicting the crossfall here. We want to be able we can use that later on in other snippets. The library one try curve profile. Try curve profile has the same idea with the user-defined naming convention, but it also has the standard 4 names to pick for your curve. These are only just an idea, for the user, but obviously you can specify your own names. This one allows you to pick the 4 strings for, say, a curve barrier or a rollover curve, but it also allows you the 4th string to be optional. So in that case, then you can just pick a 3 strings that might be a curve-only profile. Here we're looking at the ones with the 2-point name grades. So anything with the word name grade in the title refers to the use of the surface that we specified here, for instance. We're going to use that name grade for the AC surface to project the pavement underneath the curb. So again, this is linked to the strings in your curb above. And we select the name grade. Name grade 1 is this one here. Then we do the name grade down, which could be a batter slope. In this case, it's a vertical. And we're going to return using the name grade from the road. The horizontal and vertical ones have an asterisk next to them. They are automated. The other ones are all created by the snippets. We're also able to extend using the offset values from that string out to 150 mil. Once we've finished our design and pavement, we can go down to our intersection cleanup. In this case here, we just let the shapes and strings go through the intersection. Now you're going to come back and clean up the strings that we don't want. There's the addition of a new option called remove layer. In that case here, we're able to just, rather than having to pick individual strings, we can just say we want to get rid of everything to do with the curb layer, the pavement under the curb, the footpath, any grass options that go through the intersection. Again, we're using our alias start and alias end that we set up in the start here for intersection 1. For the design side of things, I didn't want to take out the entire design layer, so I'm just using the traditional only fixed. So in this area here, I'm just returning, I want to keep 2 strings. I'm using a -2 value to define that. At the other intersection, I'm going from the name KLL outwards. I want to get rid of everything else outside of the KLL string. The tri-meshes here are produced using a regular method, which means that the tri-mesh is not produced if all the strings don't exist. So you have a tri-mesh on this side of the intersection and a tri-mesh on that side of the intersection. Here we're able to introduce into our design a water trench and a water service. In that case here we insert a string that defines the centre line of the trench, and we use our standard library tri-mesh 1-point trench. In that case here, it specifies that the string that you produce is in the centre of the trench, could be left or right. It also specifies a depth. You can use a link if you want the trench to be locked into a surface string out here. We're just using a depth. We're also doing using the name grade surface, FPL, which is this surface here. And that surface was created when the tri-mesh for the footpath was created. So it's using that to define the top of the trench. The great addition of V12 is the ability to set attributes to elements in the design, including tri-meshes and the water service. So here I'm selecting the tri-mesh, and it's a water utility, and specifying what type of utility it is. It's water. So again, specifying the pipe size, the material of the pipe, all those attributes. Here we're setting up the AC surface, the depth, and what type of surface it is, and same for the base and sub-base. So we use F8 here and select our tri-mesh. Under the utilities, we have the type, size, and material. Pick the pavement. Again, under pavement, we have the material type and the depth. So all these attributes are great information and can be used in general reporting, BIM, KML, and ADAC. On the right-hand side of our road, we're using the fixed interface to 10. This option allows you to do thing which you can then modify using all the normal modifiers, and it's not limited like the final cut and fill would have been. So in this case here, though, it's doing a slope down to a tin surface, and we've done other modifications to our road, super elevation and so forth. So now the interface to the tin hasn't been revisited. So there's an option to say dynamically update. So I can say yes, that means every time the other modifiers are run, it will then come back and re-interface to the tin for you. So I apply that. And that's just now re-interface to the tin surface. So just set that dynamic update. There's also some warnings here. So look at the warnings there that they're concerning there's no intersection with a tin. I've got a hole in my design purposely done, but you also could have a lack of survey so that you know that the interface doesn't hit and you don't necessarily want those warnings reported to you every time. So in that case, you've got a no interface, do not error. So I can just say yes to that, and again, when I run, I won't have those errors. There are occasions when you might do a modification to a interface slope. In that case here, around here, you may want to change from one slope to the other, but you don't want the dynamic to override that. So there's a fixed re-interface to tin. So in that case there, if you've got something special, you can just simply pick that up and rerun it. And the automatic dynamic update won't be affected. Let's modify using alias over the areas of the pond. So we have a look at the alias here. It uses some of the new ones. Again, there's ones here called true lowest drop change, true highest, lowest of all drop change, and highest of all. So in that case here, it then picks the true value. So the alignment string here starts in the pond, runs all the way around and finishes back here. So it actually gets the true change. So it gets the most extreme point, drops it down to the center line, and so forth down to here. If you pick the other one, which was the true lowest of all, it would then pick the start point of the alignment string, change to 0, and drop that down to the alignment string. Our better slope is now set at 1 in 4. For jobs like our overlay and widening job, again we can create name grade steps for the road profile and the any of the better slopes, and produce using a snippet from the library, extend the pavement out to the edge. Okay, and all those ones have the name grade involved in there. You can specify or set name grades manually, not just rely on the snippets. In that case here, we're using 2 links to specify the hinge string and the edge of shoulder, and we're calling it a name. And here we're seeing this is a better one from edge of shoulder down to inverted drain. There's also a good one here called link and tin, where you specify one link and a tin surface and whether you want to get the slope from left or right side. Quite useful in the occasion where the inverted drain string may disappear. There's also a snippet available in the library that will do the corrector service or the infill, which just picks points. It's a mandatory 3 layers and optional up to 6. That way you can reduce this corrector surface. The retaining wall option here was created using a snippet, but they use a definable one outside of the snippets that are in your library. So design MTF snippets, you can go create tri-mesh. So we're using a profile option here. So now wall profile, we can select the wall profile. You can now specify the names inside that get created inside the MTF, either as vertices, string name plus vertices. If it happen to be vertex text or point IDs, you can use those. Here you can also set the individual segment color for the tri-mesh, in case you want to better see a textured profile on this surface, but maybe just a solid color here. Tunnels are produced in a similar way. Design tunnel surface. So here we've got a profile for the main part of the tunnel, an area that refers to a vented area, and we're going to snippets from profile. And we pick the string that it creates a snippet information of that profile similar to what the wall was like. There's a modifier added in the B12 for tunnels defined by vertical profiles. There's a modifier to stretch the heights relative to the centre line to maintain grade clearances, fixed boxing stretch heights. So the tunnel is created using an MTF and the snippets created and in your apply many. So again, we just got the snippets with the variety and transitions from main to vent. Here we're looking at the creation of the tunnel shape. It uses the option for varying internal links. So in that case here, as long as the first and last string are continuous along the tunnel, the other strings can come and go and the shape will still be processed. Look at the tunnel profile and F8, so here's our tunnel centerline. and it has information attributes stored that 12D field will then use. There are lots of new modifiers in relation to trimming strings back to tri-meshes for the connection of tunnels and bridge abutments. There's also one for trimming overlapping sections in our pond design here. Got some overlapping sections, we just want to tidy those up. So you simply just bring up the command, say what layer that belongs to, and run that. We'll just take a quick look at the other modifiers that are available. So under insert, we can insert around an arc. So you can do that for tunnel preparation and also rounding on shoulder through. Under remove, we've already shown you remove layers, trimming links to tri-meshes and so forth, and then the one we just showed, overlapping sections. Under decisions, you can now do decisions in relation to tri-meshes, similar to what we do with tins. Under link exists, for instance, besides looking for a link on a layer in your MTF file, you can also check against an external string and then whether or not you're either side of that string. The rename option here has a twist to it. If you decide to leave the link name here blank and then possibly want to name all the strings INT, then all the strings at the end of the section profile will be named INT. As possibly mentioned before, under design volumes, you can now report the volumes along the string in relation to a tri-mesh. We've got a small chain here, we just run our volumes. And here we specified our AC surfaces left and right, our pavement A and B, and also the wall information.
Thank you, Peter. As you can see, you can do all that in the MTF, as complex as if you like, or using the simple tri-meshes, you can do it very, very quickly. But you can do it all without going outside 12D model. Right, now we're going to have a look at some more of 12D Synergy, not as much as yesterday. We're going to look at a very special part here. This is something 12D Synergy for data synchronization. And the example came from how it can be used in construction, but for surveyors, also for detail surveyors or any group of surveyors who are bringing lots of information together. So we'll let Joel explain that to you.
Hi, my name is Joel Gregory and I'm the General Manager for 12D Solutions. Today is part 2 of the What's New in 12D Synergy version 3. In part 1 of this series, we gave you an overview of most of the major features coming in the product. In part 3, we'll be covering the file replication servers, and that will be run by Richard Stollier, our technical lead. However, today's session, I'm going to focus on the data sync tool for construction companies. We started by meeting with survey managers from major construction companies across Australia and New Zealand. We showed them Synergy, they loved it, and they told us about a problem they were having synchronizing data from the central database model that the survey managers were manipulating and pushing that data to the surveyors who may be using 12D field on a Windows-based tablet. So we thought we could integrate a lot of these tools into 12D Synergy. The limited or inconsistent internet available on these construction sites was a real limiting factor to what we had to create with the Synch tool. Particularly on major tunnel projects which have adopted the product, internet isn't available at all. 12D Synergy has a really robust 12D model check and check out possible. However, this isn't possible for a lot of projects in the field if the internet isn't actually consistent. And not just the internet connection, but the survey managers didn't actually want to have to manage entire 12D model projects being pushed backwards and forwards. They preferred just importing the 12DA, the field files and other reports that they needed to get the job done, and just getting an audit trail on those specific files rather than the massive projects that end up being in 12D model. So we spoke to a whole load of clients all over Australia and New Zealand, survey managers, surveyors, and really specified their problem that we could overcome. Now, first of all, it was about sending data from a central database that the survey manager is working on and pushing that data to the tablets that the surveyors are working on. Now, that could be set overnight, or alternatively, it could be manually set whenever the survey manager wished. Now, the reality is tablets may be disconnected for long periods of time. So a full shift, 8, 12 hours, the tablets could be out there, particularly in a tunnel environment where there'd be no internet available. The reverse would also need to be possible. Data from the tablets at the end of a shift need to come back into the central database model. And again, this could happen automatically when the surveyor brings his tablet back in the office, or when he manually selects it, maybe if he did have an internet connection. Now, this whole process, the download and the upload, there needs to be a complete audit trail every time the data is moved across. And similarly, the survey manager and the surveyor want feedback. They want to know if the data has successfully transferred, or they want a warning if some of the data hasn't transferred, because there's nothing worse than synchronization where it's actually failed, and you don't know that it's failed, and you can continue working thinking that you've got the most up-to-date data, but you haven't. So that feedback loop is really critical. The other key thing here too was reducing the data footprint by only sending the change data. You don't want to have to send more data than you want to, because the network speeds aren't always the fastest, and the more data you're sending, the longer it takes. So we came together that this was the general workflow that we had. You had a central database model controlled by the survey manager. He's got some natural surfaces in there, design data, and some documentation. Now, when he's happy with that data set, he will then push that data to the individual surveyor's tablets, normally ruggedized PCs that they take 12D field into the field. At the end of the shift, the surveyor will come back into the office, and either automatically or manually, the as-built surveys, field files, and the QA reports will be pushed back into the server. Now, there's opportunity there to pass QA checks that are required before that data is then integrated back into that central database model. Now, every step of this process, there's a full audit trail. Everything is managed, and the survey manager has complete control of the process. This diagram gives an overview of the synchronization process. You can see the survey manager, using the 12D Synergy client, will create a task, select the data which he wants to synchronize. He'll also select the user or the teams of users that will be synchronized that data. Then the sync tool will actually process that and synchronize the data across. When it's completed, for each individual user, there will be the task will be completed, and an email update will be notified once it's all completed. The other direction is quite similar. After a day's work, the surveyor selects the appropriate files, the 12DAs, the field files, the QA reports. He then uploads it back to the central server. Importantly here, the survey manager will be notified when there's data waiting to be reintegrated and run through the QA reports. Because there's no point in the data sitting there waiting to be added, and the survey manager doesn't know about it. So getting that feedback is really important. You're also in control on when the synchronizations take place. So you can configure the syncs to wait for instructions from management. You can prompt the user before running, or you can make sure that it's always running at certain times. So for instance, at midnight, the synchronization will happen, and then it'll download all the information at 5 AM to make sure that for the next shift, everyone's ready with the most up-to-date data. The upload process is easily automated using chains or macros, which will go collect the appropriate data and upload it back to the Synergy system. Surveyors are quite used to running on a toolbar or running a macro, so it should be a very straightforward process. So that's a very high-level overview of that data sync tool, and it's got a lot of interest and being widely adopted in the construction industry, both here and over in New Zealand. So if you'd like any more information or a more in-depth demonstration, certainly get up. We'd be happy to take you through it. This ends part 2 of the What's New seminar for 12D Synergy. Again, please watch our other segments to see all the other features available in version 3, including tomorrow with the file replication server being hosted by Richard Stollier. Thank you very much for your time.
Thank you, Joel. As you see, all those problems of not knowing you've got data that's come in and whatever, that all can be solved, because having that audit trail these days is so super important, and 12D Synergy can do that for you. Right, now we're just going to look at point clouds. Point clouds are being used by everybody now, surveyors, designers, water people, And we have a number of options there, and some of them are already there in version 11, and we increased things for version 12. With the point cloud input, we've had the E57, which is a standard format that people can use, the Faro special format of the FLS file, the LIS, which is another very commonly used format, and also the very specialized Leica ones. A lot of these were in version 11, but each of them keeps getting changes because extra things are added to them. The new ones we've actually got, though, is for the Leica, the SDB point clouds for the new machines, the MS50 and the MS60 has been added in, and also the GeoTIFF DEM. But you can bet there's all these new ones coming out, so we'll have to keep adding to them. Here's a scan we've done with a Faro at a conference we were at in New Zealand last month in Christchurch, and it's Joel, I think, sitting on our stand, and you can see where the scanner was in the middle, the round big black dot, because it can't scan just down at the bottom of it. Now that looks fantastic. You can see everything there by eye, but when it comes to using a point cloud, it's how you actually get to that data to be usable is the important thing. And so we keep adding more options in to get usable data out of a point cloud. And they're under our point cloud management. And basically you've got categories, and you can delete and undelete points. So with the categories, what you can do there is a lot of point clouds, the IS ones that is, come with what they call a category. And so these can be turned on and off. So the people will classify them. Some will be ground, low vegetation, buildings, and so on. So you then can just pull in the data you want, so you can use it for triangulations or other things. We can also set categories from within inside 12D model using various methods. The point cloud delete options, the point cloud is just a big blob. So we don't actually delete a point out of it, we can turn it off, and then we can bring it back on, a bit like you can turn off triangles in a tin. So they're available. There's a new one here called Point Cloud Drape. That's what I've called it, and it's actually got two modes. There'll probably be two options. There's one of them where you basically pick a string, and it's got no Z values, and you just set a width, and it'll look either side of the string in that width, and look vertically down and up, and it'll grab the Z values you've got there and make a string out of it. So it's basically like then really draping onto a point cloud. The other way is slightly different. In this case, you give also a height range, so plus and minus for height, and then your string has Z values, and it'll go around and grab everything within that little rectangle, and again make a string of it. This is very good for doing QA, where you've maybe used a point cloud to pick up an existing string or a design string, and so you can get a string out of the point cloud and then compare it with that design string. Another one, which is similar to the last one, though, is just basically doing exactly that, taking a string, defining a box of a width and height, then just pushing it down the string and take the points out of the point cloud. So it's a way of pulling out, fencing out data from the point cloud. So, for example, if you know your data is supposed to be a road, but it's not very hasn't been categorized very well, if you put a rectangle down which is not too far at the height of the road, not too far to the left or the right of the width of the road, you know any points outside that are of no use to you, and if you drive that down, you can reduce the point cloud by quite a large factor. Now, tadpoles. These are also known as cut and fill marks or hasher notation. We've had them in 12D in a variety of ways for quite a few years, but we keep getting requests to beef them up to cover all the different cases. The main thing people want to do is just get away from having to do any manual drafting of tadpoles. So Pete's going to run through what we can actually do now, and hopefully it'll satisfy all your tadpoling needs so you never have to draft one again.
New tadpole options are under strings, label, cut and fill. Before we look at the tadpole definition panel, the tadpoles can be run under the new tadpole panel outside of your apply menu. But in this case here, we're going to go down to our apply menu function and run our new tadpoles from there. So the tadpole advanced tab, we select the style. We don't want to explode our labels. If we do, we can then add them to our perspective view. A strings model, which are our design strings, and then model for the tadpoles. We've got a definition panel. To create one from scratch, you simply just go to the plus button, add in a style. In that case here, we can call it, there are some help. Every time you click on one of these little lines or entries, there's a help information down here for you. So we might give that a name, drop down to our style here. This is where we're at our sub-style, we're in cut. Then we add in scenarios for single, paired and triple links. So single links in this case would be our interface string. I'm in cut. So it will then tadpole between the interface string and the next adjacent string regardless of its name. So rather than having all those, we'll go back to the one that we've already prepared. We'll look at the fill scenario. Here we're looking at the IA string, the single string. So again, it's going to tadpole to the next adjacent string regardless of its name. If we wanted to stop at a certain string, then we would enter a name for the exclude part. Under constraints, we can limit the creation of the tadpoles. So if we actually have a minimum length here, then of say 5 meters, then it wouldn't produce tadpoles in this congested area. The intervals can be set as a ratio. In this case here, it's a ratio, so it uses the 1.5 ratio value multiplied by that to determine the interval for the tadpoles. Obviously, if we just go fixed, we can write out the file to the tadpoles files and recalc our road. So the tadpoles are now at a standard fixed interval. While we're in the fill area, we're also looking at the median part. So the median is made up of paired strings. So we're looking at the paired string MDR down the center and the MD1 on one side and the EPRL on the other. So they're just basically two strings. The two strings are adjacent. So the option here for the two strings is if it's free, it will always tadpole. If you say yes, it will only tadpole if there's nothing in between the two strings, and obviously no means it won't tadpole at all. That's what our road looks like in fill. So we'll use our new favourites, our view favourites for positioning, and go to the cut area. So the cut area, again, has single strings. So the IA will interface or tadpole down to the string regardless of its name. So in this case here, it'll go from IA to the edge of pavement string, and then suddenly when it gets to here, it'll drop down to this ICL string. On the other side of the road, however, we've got a exclusion on the right-hand side, so the IBR string, where that string exists, it will not tadpole from the IA down to the string because we've got a special situation for that. On the paired strings, on this side here in cut, we're looking at the edge of pavement string or the edge of shoulder string and the batter, the IBL. So a small little batter line there is being ticked or tadpoled using the paired option. On the other side of the road, it's a triple string, a little bit more complicated. So I was looking at an IA string and a string in the middle here called IBR, and also then your EPR string, your edge of pavement or edge of shoulder. So basically, we're looking at the slope generated between these three strings. So we look at the deflection between IA and IBR and the EPR string, and if it is greater than 5 degrees or 5%, it will produce the batters from one string to the other, as shown. If it's less than that, it will just go from the first string to the third string. So again, to look at that in our perspective view, we're using our favourites. So you can see here where the batter slope is actually different here. It was greater than 5% difference between the two. It's now gone between the three of them. Well, here it's just gone from the interface down to the edge of shoulder. The symbols are just specified down here, obviously the style and a colour for your symbol. The tadpole definition is a big step forward, but also should be used in conjunction with a good naming convention inside 12D.
Right, thanks very much, Pete. So if there's anything we can't handle with your tadpoles, just let us know so we can eliminate all that drafting for you. The final thing we're just going to quickly look at is Rob was just going to show us how we can actually have a height rendering for tins rather than doing individual triangles. Use a spread of colours and also then create a legend to go with it.
When we view a data train model or a tin inside 12D's OpenGL 3D perspective view, you can easily see the topography, but sometimes a bit of coloring will help accentuate this. To add those bit of height coloring, we'll go down to Design, we'll use the tool menu and use our tin height legend. With the tin height legend, the first thing we'll do is select the tin we're planning on coloring, and if we have a color strip that we like to use, we'd simply select it here. Or if we want to create a new one, I call this My Colors for Heights, and we can select a range file. Now in our library, we do have one called Rainbow, which contains some bright colors. Let's just go take a look at that. What it is, it's a set of colors from a dark blue up to a red to a very dark color here, and this covers a range of 30. We don't actually use the elevations from this. What we use this is to proportion the amount to be used for each color. So this has a total range of 30, and you'll notice that each one of these increments just happens to be 3 meters. So each one of these color blocks will take 10%. So moving along, we're going to put this into a model called Legend, and it does have to have a real-time height, so I'll make that 100 meters high. We'll put that at location 00, or we could pick a place near our project. The name of these, the tin gets automatically loaded. We can change that as well as the scale title. We may not want to use the actual minimums and maximums from our DTM. I think I'm going to go with a minimum of, let's go for a minimum of 10. Let's go for a maximum of 160 and make each one of those increments 15 meters. So once I've customized that, I can select the Create button. And because I have the tick box under the Enable Height Render, the first thing that will happen if I redraw my view is I'll see that coloring on that view. The next thing I might want to do is to create a new view so that I can see the legend. And we'll go create a view, create ourselves a plan view. I just call that legend in case I'm looking for it later, easy to find. And I'm just going to make that just a little bit smaller. And why don't I put that next to the tin that we just colored? And I'm going to add on the model called Legend. So what I've got here is I've got that color strip legend with those colors, and I've got a colored data train model or tin.
Thank you, Rob. And that's the end of today, part 2. What we've looked at is view favorites and view positions, which I'm certain you'll use all the time. The dynamic water supply, it's a new module for people. The MTF and Snippets just show just how complicated things can be handled very easily inside 12D model. The data sync with 12D Synergy, which I think they'll find lots of uses with that. Point clouds, tadpoles. Now, that's the end of this seminar. The next future one is tomorrow. So it'll be on same times, 4 times tomorrow. That'll be the final one, and I'll answer various questions that people have asked along the way as well. It will again be different to these two. And the other thing again, to remind you, get in for those innovation awards so you can actually win some of the $15,000. You don't have to come to the conference to win the money. We're just going to give out the prizes at the conference. And of course, if you can make it to our conference in 24th, 25th and 26th of July, we'd love to see you. It's up in Brisbane then.
Thanks, Lee. If you enjoyed today's webinar, keep an eye on our website for upcoming webinars in our Industry Solutions and Training series. We'll keep updating it with many more topics in coming weeks and also keep you posted through email and social media. And don't forget, as Lee mentioned, we've got our next 12D International Conference this July with the associated Innovation Awards. The awards closing date is the end of May, so if you haven't submitted your entry, now's the time. If you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you for attending. We'll see you at the next webinar.